right, Chapter 7 is all about exponential functions. Today, for 7.1, we are going to talk about exponential growth and decay. First of all, an exponential function is always in the form y equals ab to the x, where a is your start, or you can think of it as your y-intercept. The b value, if b is greater than 1, then it's a growth. If b is between 0 and 1, it's decay. So let's talk about growth first. Ooh, that's not very straight. An exponential growth, let me try and make that a little straighter. All right, it's always going to cross at A through the y-axis. Now, if it's a growth that starts really, really small, really small and increases faster and faster and faster. Okay? If it is a decay, it starts large and decreases quickly at first and then slows down and gets closer and closer to 0. But it never, ever touches 0. And again, it crosses the y-axis at A. So those are the two things we're working with today. In the first section, we are going to graph a few growth and decay functions. So here's example number 1. This is what I'm going to ask you to do for 10 through 16. I'm going to ask you to graph. And on your paper, let's say I have y equals 2 times 3 to the x. I'm going to have you do a table. In our table of x and y, the 5 x values we're going to use today are -2, -1, 0, 1, and 2. So I'm going to plug it into this. So I have 2 times 3 to the -2. 2 times 3 to the -2, if I plug it in my graphing calculator, hit math center, enter, I will get that this is 2 over 9. Remember that 3 to a negative exponent moves it to the bottom. So that also gives me 3 squared on the bottom, or 9. Next one, I have 2 times 3 to the -1. This is 2/3. I have 2 times 3 to the 0. This is just 2. I have 2 times 3 to the 1st, which is 6. And then I have 2 times 3 squared, which is 18. Then all I want you to do for your graph is you're going to draw me a upside down T. I want you to do 2 dashes to the left, 2 dashes to the right. And you can decide how far you want to go for 18. So we can go by 2s. Let's go 2, 4, 6, 8, 10, 12, 14, 16, 18. All right. So at -2, I'm going up 2 ninths. So barely above the x-axis. -1 and 2/3, so up a little bit higher. And again, remember, we're going by 2s. I have 0, 2, so here's my 0, 2. 1, 6, so here's 1, 2, 4, 6. And 2, 18. So you can tell that this is a growth. right? It's really close to the x-axis to start, and then grows bigger and bigger, faster and faster and faster. Okay? Let's do one more. Yeah, no problem. You just, 2/9 is barely, I mean, it's 2/9 is little, right? So it's just barely above the x-axis. Just kind of approximate in there. Okay. So let's go with, go 2 times 0.5 to the x this time. So first of all, my b value here is 0.5. So is this going to be growth or decay? It's going to be a decay. It's going to get smaller. So let's see what happens. In my table, I'm going to do -2, -1, 0, 1, and 2. So I have 2 times 0.5 to the -2. I believe this is 8. Somebody want to put it in their calculator and make sure I'm right? Okay. Then we have 2 times 0.5 to the -1. It's going to be 4. 2 times 0.5 to the 0 is 2. I have 2 times 0.5 to the 1 is 1. And I have 2 times 0.5 to the second, which is 1/2. All right, again, I'm going to make a upside down T, 2 dashes to the left, 2 dashes to the right. This time my largest number is 8. So 2, 4, 6, 8. If I want to go that way, you can count however you want, whatever works for you. First one I have is -2, 8. So I go to the left 2 and up to my 8. -1, 4. -1 and up 4. 0, 2. 1, 1. And 2 and up 1/2. Then I connect my dots. You can see this is decreasing and getting closer and closer to the x-axis. So you really only have 4 of them that you have to graph today. Any questions on graphing? Oh, perfect. All right. Example number 2. For example number 2, we're going to cover 18 through 24. And without graphing. You like that idea, don't you? State the y-intercept and the growth or decay factor, which is your b value. So let's say I have y equals 1.5 times 4 to the x. First of all, my y-intercept is my a. So I'm going to say a equals 1.5. My b value is 4. That is bigger than 1, so I'm going to say this is growth. All right, let's say I have y equals 1.7 to the x. What is my a value this time? Ooh, what magical number is always there? A equals 1, right? My b value is 1.7. Is that greater than 1? So this again is a growth. How about y equals 3 times 0.25 to the x? And this one, my a value, that first number is 3. My b value is 0.25. But this one is between 0 and 1, so this is a decay. Decay. All right, so you have a few of those where you just got to state that. Any questions on those? Okay. All right, next. I want to talk about exponential growth. The equation we are going to use is y equals p times 1 plus r to the t. 1. So p, again, is your starting amount. We call it our principal. The r is your rate as a decimal. And t is time, or number of years. If we have exponential decay, the only difference between these two formulas is that it's y equals p times 1 minus r to the t. So if something is decaying, depreciating, getting smaller, it's 1 minus r. All right, so here is example number 3. And this is going to cover 26 through 28. And again, today is all. I forgot that. So you have to grasp 8 of them. I apologize. Okay, so let's say I have a population of 5,280 people, increases at 7.5% each year. How many in 10 years? So we start off with y equals p is the number of people we have to start with. Yep, 5,280, right, Kaden? Okay. Parentheses, since we are increasing, it is 1 plus. Now, how do I write 7.5% as a decimal? Good. 0.075. And how many years am I looking for? Good. Now we're all going to grab our calculators. Because it's taking your whole population, which is one full population, and then adding 7.5%. Yeah. You got to swoop it over twice to get it to a decimal. All right, now here's what I want to talk about. Remember that if you have part of a person, you have the whole person, so we're always going to round this up. Okay? So it's still a person if you don't, if you have part of them, you have all of them, or they wouldn't be called a person. We're still going to call them a person. Okay? All right. Do one more. Example number 4. Suppose you deposit $2,000 into an account increasing, that's an E, by the way, by 6.2% each year. How much in 12 years? I don't know. I haven't put it in yet. We start off with our starting amount, which is $2,000. Then we are increasing, so it is 1 plus 6.2%. We swoop that over 2. Good. 0.062 to the 12. Grab our calculator. All right, now, with money, I'm going to have you truncate it. Cut it off after 2 decimal places. Okay? Should be 4, 6. Oh. Okay. So, do we have any questions? If we decrease, what would change in that formula? It would be 1 minus. Absolutely. Okay? This is a super easy lesson. You're just approximating where it goes on the graph. I'm looking for the y-intercept, and that is either increasing or decreasing. Yes. Yeah, fine. All right. You guys got this. Yep, just a second. So again, we're doing page 439, 10 to 28 all. I don't believe it's going to take you very long.